So welcome to Advanced Calculus. Well, let's take a look at this worksheet you just got. This is called Implicit Differentiation. And I'll find it. Okay. Okay, guys, looking at this here worksheet. Okay. Number one, problem number one. What if I ask you to find the derivative of it? How is it different from every problem you've ever found the derivative of?
There's an X and a Y.
An X and a Y. Guys, this is called multivariable calculus. And oh my, they got whole courses devoted to this. Okay. So I want to show you what to do if you got to find the derivative of something with more than one variable. And I'll show you two problems. You can practice one or three on there and check your answers on the back. And we're good. Okay, so how does one do derivatives when there's more than one letter? Okay. So here it is. Boom. What's the derivative of that? You've done it. 2x. But here's what you didn't know. You're supposed to have written 2x, of course, but you're supposed to have written this. I just took the derivative of something with x's in it with respect to x. Why didn't you ever write that? Because what happens to it? Cancels out. Okay, that's why nobody ever does that. However, you can do that here. And that's just 2 what?
2y.
2y. Well, you'll say over here, I just took the derivative of something that had y's in it with respect to x. And that doesn't cross out. And then what's the derivative of this guy? Don't strain yourself.
0.
0. Okay. Now, you're going to have to go back to day one of derivatives where I told you that derivative could be written one of 3 ways. What was the third? Y dx. Okay, so you're done when it says dy dx equals. Get this guy by himself. You got to move first. Yeah, the 2x, which no longer has the dx beside it because you crossed it out. Okay. Create a little room here. Okay. So how do you move that guy over here? Subtract. So now we have negative 2y, y dx equals negative 2x. Okay. And then what's your last step to get rid of negative 2y times dy dx? Divide by. So you said divide. Okay. Now a little algebra 1. Cross out the 2's and negatives. What's that?
Excellent.
Why don't you check the back? Is that the answer number 1? Checking. And there it is. That's how you do in one problem. Implicit differentiation. Okay. So why don't you try number 2, or I know we'll try 2 together because it's slightly different. But you're already armed with enough skills to do it. Okay. All right. Find the derivative of this. What do you see? Is this power rule, product rule, quotient rule, chain? Who's this? What do you see there? Products. Oh, that was the one that was front times derivative back plus back times derivative front. Okay. So fill it in. What's the front? X. Now I need derivative of the back. Nice and easy. One, and what did we just take the derivative of? Y. Y. So that is front times derivative back plus back. I got you. And real quick, what's the derivative of front? 1 dx dx. I'll write it just so you see it, but it's gone. Okay. So anytime you take a derivative, you write the dy dx or dx. Okay. So there's the answer. We just got to clean it up. Okay. Oh, almost. What is the derivative of this guy again? Okay. So right, equal 0. And why don't you get dy dx by itself? You can get the final answer. Okay, get me a little help here. I got x dy dx plus y equals 0. Get this by itself. What are the two steps? Well, you're not wrong, but always move what's furthest away. What's furthest away? So minus y and then divide by x. So the answer should be subtract y divided by x. Is that correct for number 2? Yes. Okay. See about that. Number 2 is boom, negative y over x. Perfect. Okay, I think you get the concept, but you could use different rules like product rule, quotient rule, whatever. All right, one last problem. Number 8, I think. Oh, I lied. Number 11. What's different here? Yeah, they want the slope of the curve at a given point. All right. I've never said it, but your calculus teacher is going to probably tell you on the first day of school that okay, derivatives are used to find the slope of the tangent line. So the minute you hear this, okay, be thinking about derivative. Okay. So here we go. Step 1. Let's pick up some speed here. Okay, that's just plain old 2x. I'm not even going to write the dx over dx anymore. We're beyond that now. Took 2 problems. All right, and then this one, nice and easy. 2y, but I need dy dx. And you love this. What's the derivative of the constant? 0. So there's step 1. Solve for dy dx again. Give me what 2 steps? Minus 2x and divide by calculus. Yes. So subtract the 2x and divide by 2y, which gives you negative x over y. If this were problem numbers 1 or 2, we'd be done. Okay, but guess what? You can find slope at that point by plugging that in. So what do I got? I got negative. Plug in the x, what was it, 3? And what's the y? Okay. So what is -3 over -4? Okay. That is the actual slope at that point. Check the answer, number 11. There it is. Okay. Except it's not the derivative that's 3/4, it's the slope at that. All right. So it won't get shorter than that, but that's how you do implicit differentiation. Have a good day.